Alright, so we are going to start our linear functions, equations, and inequalities notes. So after you've folded this together and stapled it, it's going to stay in your journal. But this is the part where you're going to fill out the notes in this little booklet. If you need to take additional notes, you'll take it under the additional notes pages listed in your journal. If you look at your table of contents, we're going to go over pages 1, 13, 14, and 15 today. On page 1, we have linear functions, equations, and inequalities. Here's some symbols to remember. We have the infinity symbol, the plus or minus symbol, this upside down A, which means for all, this E right here, there exists, this rounded E, there's an element of, the 3 dots that make a triangle, therefore, and then the U for union. Equals is the equal to, equal with the slash in it is not equal to. We have the less than and greater than symbols, and then we have less than or equal to and greater than or equal to. One note about or in math, if you just put or, it means and slash or. And capital O and capital R just means or. So the first thing you want to fill in is that linear is arranged in or extending along a straight line. Plotting points. So parentheses x comma y close parentheses are formally named Ariska and ordinate. So try these examples, pause the video, graph this on the number line. -3 is less than or equal to x, which is less than 4. We'll go ahead and talk about these examples later on in class. And then the next example is label the 4 quadrants, 1, 2, 3, and 4. Plot the points T, -2, -3, E, 0, 3, and A, -3, 1. And then identify the points X and S on the graph. Where's the origin? Label that as well. Okay, on page 13, you can go ahead and try this now. We will go over it in class. Finding an example, given data that fits perfectly. So write an equation that best fits with the equation, with the table. We have x equals 1, 2, 3, 4, 5, and 6. So for one shoe, that would cost $32.50. If you bought a pair of shoes, that would be $65, and so on. So you're going to write out 2 test points, your change in y, and your change in x, and then you'll find the slope. And then using that, we're going to put our equation in slope-intercept form. After you've done that, go ahead and plot the points and graph this relationship. Put 1, 32.5, 2, 65, and so on. After that, write a couple sentences to summarize what this means. On page 14, we have ice cream for x variable and crimes events in the area for y. So go ahead and plot these 3 points and then find the slope using these points. They will not all be the same slope, by the way, so you could put no in that blank. After you've done that, make a scatter plot of the 3 data points. Then draw a trend line on the scatter plot. A trend line provides a reasonable fit for the collected or given data. Okay, page 15. Finding an equation giving data that does not fit perfectly. Old Faithful is a geyser in Yellowstone National Park. The table shows the duration of eruptions and the time interval between eruptions for a typical day. So we have our duration in minutes, and we have the time interval in minutes between each eruption itself. So the steps for putting data into the calculator will be this. Go ahead and open your TI Inspire. You will go to this icon. It's basically new lists and spreadsheets. Under one of the columns, we call it X. And then the other column, we could call that Y. From there, we will input all the data that we see on that table. Once you have inputted the data, you're going to go into the C column and press Menu, Statistics for Stat Calculations, and then we're going to do number 3, which is Linear Regression, MX plus B, which is our slope-intercept form. For your X list, you're going to select X. For your Y list, let's select Y, and then we'll press OK. And then OK again. Let's have it in this box right here. So Menu, Statistics, Stat Calculations, and then Linear Regression. And then Enter. You should get something that looks like this. From there, you'll write what M equals, what B equals, R squared, and R. So go ahead, write those steps right here. Go ahead, rewind the video if you need to. Write the steps in a way that you can remember how to do this. And then fill out these blanks. So the number that measures the strength and the direction of the correlation is the correlation coefficient R. R is between -1 and 1. The closer R is to -1 or +1, the less scattered the points are and the stronger the relationship, the closer to a perfect fit it is. And then the determination coefficient is R squared, R to the second power. It's a statistical measure of how close the data is to the fitted regression line of reasonable fit. So go ahead, write down why would we want to calculate a line of best fit? Write that in a few sentences.